Okay, you guys. So here's the deal. Now we got to learn how the heck to use these logs. And it's like, what is going on here? So check this out. This is where we're going to get a little bit uncomfortable. We're going to start with this rule, though. And I just want you to know, because of logs, do you see where this exponent is a p here? Yes. Do you see what they did over here? They kept everything the same. What did they do with that exponent? They just brought it out front. And that's just a rule that we're allowed to do. So let's go look at the example of this. I left it kind of blank so that we could fill it in. What would this be the same as? That exponent could go up top or out front. Makes no difference, but we could say that's equivalent to log base 2 of 8 to the x. Thanks for that, perfectly saying that way. When a function has a log or a natural log involved, we'll get to natural log, the exponent can go out front or up top. That is just a rule that we get to follow. So we're on page 27, Mr. Wilson.
Yikes, Wilson. Yikes. Sorry. It's okay.
The other thing I want to show, and then I'm going to do an example, is this one right down here. Check this out. They said if log base b of m equals log base b of n, what happens?
N equals m.
Yeah, what'd they do you think? Did they kind of go like this? Push, push.
Yeah.
And m is n? That's all that's left? So, could I do that here?
Yeah.
Do the log bases match?
Yeah.
Do they need to? Yes. Do you agree this is log base b and that's log base b? If those bases match and I have one log equals another log, you get to go like this. Boom, boom. What's left?
3 minus 4 equals 20.
Yes. Go solve for x. You're like, great, these rules, awesome. Let's take a peek at this right here. Here's what I'm going to show you guys. Ready, Margie? Ready, Sammy? On this number 14, do I have 1 log equals 1 log? You with me, Ireland?
Yeah. Cut it up.
Yeah, that thing looks weird.
I got a 1 log equals a 2/3 log, don't I?
Because not this.
What can I do with that 2/3? Yes, when it's out front, you can go boop.
Oh.
Then I got 1 log base 7 of n equals 1 log base 7 of 8 to the 2/3. 2/3.
The black packer.
Now, can I say log base 7 equals log base 7? I can cancel those out.
Black packer.
You guys, if I've got n equals 8 to the 2/3 left, guys, how do I do that? Do I want to do 8 squared?
Calculator.
Nah, do not calculate it. Ready? Which root do I do? It goes power over root. What's the cube root of 8? 2, then square it. 4. So on that problem, you guys, my favorite rule is crossing out the logs. That's the best. You can only do it when you've got 1 log equal to another log. What do we do to get that to happen? Move that up into the exponent. Do I see another one like that I can do yet? Not yet. Let's go take a peek at this guy, though. This doesn't use any of our new rules yet. So this goes back to, can I type, if I'm Graham, can I type this into my calculator? I cannot because we don't know what the base is. Can I take this from logarithmic form into exponential? Cha buddy, what would be my base?
Oh, you gotta draw the circle next still.
B to the equals all that stuff, okay? And I'll explain all that stuff. So we got, totally, yeah, let me show you. So we got b to that power equals all that stuff. Why didn't I put a comma? I don't know, people. What Philip's saying is, can we just take the 6th root of that? Could I have done that right there? Yes. Anyone have a guess? I'm guessing it's 5 because it ends in a 5.
I would say 20.
Ooh, is it?
I don't know.
15, 625 to the 1/6.
Big zoinks. Oh, that's awkward.
So, for a number this big. Okay. Here we go. Guys, does anyone remember how the heck we can solve for b when it's raised to the negative 1/3?
Oh, you would
Raise it to the
-3.
Yes. Why? Because check this out. If I raise that to the negative third, you guys, what do I do when I handle power to a power? What do I do with those exponents? You multiply them. What's -1/3 times -3? +1, and I'm just left with b to the first. If I wouldn't have done another negative, I'd have b to the negative first, and that's not helpful. I just want b. I don't want gram to the -1. I just want gram. You guys, 5 to the -3rd. That'd be the same as, oh my gosh. I hope that this caught that. What do you do with a negative exponent? Yeah, 1/5 to the 3rd. What is 5 to the 3rd? Whew. Okay. That's how we handle that. Now, I got a proposal. I got a promposal, if you will. Let's go back to the beginning. Is there a different way I could have started that? What if I said, dude, I see this exponent and I don't want it? Could I bring that down?
Probably.
Yeah. So I could say that I've got 1/6. You could write this down. You don't have to, though. Log base b of the 15,625 equals -1/3. Then what would you do to start getting stuff away from b? 1/6 is being what to log? So what's the opposite? Couldn't I divide out a 1/6? Is dividing by a 1/6 multiplying by 1/6? Okay, so I'm left with log base b of 15,625 equals -1/3 times 6. -2. Now let's go exponential. B to the equals. So b to the -2 equals 15,625. What am I going to do? What is the opposite of b to the -2nd? How do I just get b? Ms. Berlin. Okay, y'all, what am I going to raise this to?
1/2.
Isn't it going to be -1/2? The reciprocal is -1/2. Ooh, wait. So I've got b then. 15,625 to the -1/2. I'll even just show you. Gram. We could do 15,625 to the -1/2. Math, enter. Is that what I had over there? Yeah. But I could also think about this as 1/15,625 to the +1/2, which is the same as 1/root 15,625. And I didn't know that, but root 15,625 is 125. Same way, same answer, different way. Ooh, let's go take a peek at problem A. What can I do with those? Can I just get boom, boom? What am I left with? All right, let's see if we can all do this algebra problem correctly. So you guys, that one, love it. Can I do the same thing on this problem, or this problem? I cannot, because you agree, I don't just have 1 log equals 1 log. We actually have 2 logs on this side. And I get that they have the same base, which is great, but it needs to be 1 log equals 1 log. What I'm about to teach you is how to condense all of these, Philip. Here we go. So, how the heck am I going to be able to get these in this mode where I can just go, psh, psh, okay? We're going to use these little rules here. Let me show you what the heck they mean. So it says, with product, it says if we ever have 2 logs being added, so if I kind of look ahead, I see 2 logs being added right there. I can condense them to 1 log. What did I do with this m and my n? I multiplied them. You get to do that. So check this out. If I want to condense these 2 logs, they have the same base. It's a must. I can condense these by saying log base 3 of, what do I do with my 9 and my x? I'd multiply them and I would just get 9x. Because these 2 logs are being separated by addition, it's very strange, we get to combine them into 1 log by multiplying this component. Okay? So bear with me. Let's go take a peek at this guy right here. How would I combine this log with that log? Log base 11 of x times x plus 1, and we would distribute it. How many people wouldn't even waste their time writing it this way? Mr. Wilson's just going to go distribute, and I dig it. Or he's going to say, I can cross it out because I got 1 log equal to another log. I love it. Guys, what's x times x plus 1? plus x equals? Okay, x squared plus x minus 6 is 0. We'd have to toot that. What multiplies to be negative 6 adds to be 1.
Three, negative 2. Right?
Does
We might have to do a recap.
Does 3 times negative 2, I'm recapping it right now. So we need two numbers that multiply to be negative 6. So what multiplies to be negative 6 adds to be 1. Plus a 3 minus a 2. Therefore, x equals.
Negative 3 and 2.
Yeah, it's going to be the opposites. So you guys, which one of these do you think is not an answer? The what? The negative 3, right? Because can I have a log of a negative? Let's just try.
We looked at the graphing calculator and it is.
Let me just go graph. Math, up arrow, log base.
I haven't tweeted
Oh,
in so long. No, like that. Like,
Oh my gosh.
when's the last time we did two?
Right. Log base 11 of negative 2. Oops. Of negative 2. Oh, shoot. That's just the value. Log base 11 of x. Let me show you guys. So you guys agree, log base 11 of just x only has positive x values. When I plug in, J-Bro, pay attention. When I plug in a negative 3 here, wouldn't this be a negative x here? Because it'd be negative 3 plus 1, which is negative 2. I can't have x be negative 2 in that graph. Here we go. You're going to just cross out negative 3, and we got just x is 2. Now, are you able to double check that on your own? Sure. So if you went just to that home screen, and I just said math up arrow log base 11 of x, and that x, if we're checking that negative 3, you'd say negative 3 plus math up arrow log base of 11, negative 3 plus 2. I'm sorry, that was plus 1. And then you see I've got that I at the end of it is imaginary again. So I cannot have my base, I cannot have that value be a negative x value, okay? A negative amount. So what we just did is we combined if things are multiplying. Y'all, we glitching. Okay. If things are multiplying, we can separate them out by using addition. Or if they're addition, we can combine them to be multiplying. Do you think the same goes for division and subtraction? Sure does. If it's got division in one log, I can separate that out. Same base, log base of the top minus the log base of the bottom. Let's go practice that here. This would turn into log base 1/4. That is not a convenient base to write. Log base 1/4 of, what do I have to do with my 4 and my 5?
4 minus 5.
Close. If we've got the 4 minus, yeah, exactly. It'd be 4 over 5. Okay? So let's practice that. Let's practice that. Down here. I cannot combine these till I have just one log and one log. So what am I going to do with that 2? Can I take this 2 and go right here? Boop.
Yes.
And can I take this 1/4 and go boop?
Yes.
All right. So that would be log base 6 of 4 to the second. I'm going to write this step because maybe people need it. Beck, I think, is going log base 6 of 16. I love it. Minus log base 6 of 16 to the 1/4, which someone might jump to the 4th root of 16.
Wait, 2.
It's 2. And then that's equal to log base 6 of x. I wish that I could cancel all these logs out. I can't until I have, thank you so much, until I have one log equals to another log. Guys, how can I condense these 2 logs into one log if they've got subtraction between them? Don't forget to make sure that we say log base 6 of, how do I combine things that are subtracting? Divide. We're going to take 16 divided by 2. Graham might just write down 8. Okay? You're going to take this divided by that. The order matters. Wow. So here we go. Are we okay with condensing 16 divided by 2? Because when we're subtracting, we're dividing, right? They go together. Then I've got log base 6 of x. Can I go wapow, wapow? What's my final answer?
X equals 8.
Yes.
Mine's blown.
Real fast, can I check these?
Yeah.
Yeah. Can I just type in this whole thing on the left and see if that equals log base 6 of x? Sure. Margie, you had a question.
Not Dar did.
Oh, Dar, what's up?
How'd you get from the first step to the second step?
First step? Oh, yeah. From this step to this step? What is 4 squared? And then the fourth root of 16. You could use your calculator if you need that, but 2 times itself 4 times gets me 16. So if I did, I want to show you guys a trick. 2 log base 6 of 4 minus 1/4 math up arrow log base of 16. And then let's go if that equals math up arrow log base of 6 of my x, which is 8. I've got something to show you. I want to check this if I didn't type in that log base of 6. Check this out. What if I just did 2 log of 4 minus 1/4, oops, I did 1/5. That's not helpful. Log of 16. And let's go see if that equals the log of x, which was 8. So do you agree hitting math up arrow log base is kind of annoying? Okay? When all those bases match, it really doesn't matter. Oh, golly. When all those bases match, it's not that big of a deal. So it could just be a nice check, skip, a nice skip checker, skipper, whatever. You could just omit the base because it doesn't matter because they all matched. Okay? While you're solving it, you can't be doing that. But checking it. Here we go. Let's try B. Can I just cross things out?
Yeah.
I wish. I need 1 log equals 1 log. Can I, what do you want to do?
Let's just figure out the.
Log 3 log plus 5 over 3 minus 2x.
Can I condense these 2 logs into 1 log because we are subtracting? Ready, healed? Focus. Here we go. Log base 3 of what? 4x plus 5 over 3 minus 2x equals 2. You guys, I wish I could type this left side of my calculator. I can't just cross out this log because I don't have another log over there. This is logarithmic form. Go put it in exponential. What's my base?
3, 2, 4x.
Wow, you just sounded like a robot. It's 3
2, 4x.
to the second. Don't just say 3, 2.
I knew what I meant.
3 to the second equals
4x 5 over 3 minus 2x.
simplify it, folks. 3 squared.
9.
We got 9 equals 4x plus 5 over 3 minus 2x. Wow. What are we doing first? What are we doing first to solve this?
Dude up there's small.
Yeah, she says multiply by that denominator. 3 minus 2x. No, only conjugate when we need a square root. What are we getting on that left side? 27 minus 18x equals 4x plus 5. Okay, go solve that multi-step equation on your own, people. You can do this. Here you go. How many years? Let's just do a little reminder. This is kind of what Andy's working on right now. Let's remind ourselves, compounded annually. How many times would my interest be compounded if it was done annually? 1 time. So we're going to use this formula. That's the P1 plus R over N to the NT. I want to turn $700 into $47,000. Don't we all, y'all? Let's go. What are we investing?
$700.
700. 1 plus, what's my rate as a decimal?
0.12.
Over N, the number of times per year. 1. To the
1.
same N, which is 1. T, how many years we got? Ooh, it says how many years? We don't know. So this is harder than the problems that I gave you. Oh my gosh, what do we want A to be? My bad. We want my final amount to be 47 grand. I didn't put anything like this on your quiz because you didn't know how to handle when we had an x in the exponent yet. We were just plugging into these formulas, always trying to find my final amount. Here we go. How am I going to start solving for x, people?
Well, I feel like
I would distribute.
we should like simplify the parentheses.
Oh, could I distribute this 700 here? No, because parentheses and that exponent, this is raised to that exponent, that 700's not. You know what I'm saying? Dow?
Oh, really? I would have so done that.
Yeah, he's saying get rid of that 700. You guys, what's 47 thou divided by 700? What's 470 divided by 7?
Force tells me. I don't know.
67.146. I don't like that.
Are you cool if I just say 0.12 instead of divided by 1?
Yeah.
Okay. Now you guys, this looks terrible. We have not done anything like this yet.
It's okay. We're gonna be okay.
Do you agree until when our variable is in the exponent, there's no way to solve it without logs? This is considered, this is considered exponential form. I got a variable in the exponent. I have to put this in logarithmic form. That's the only thing that's going to help me here. So, do you agree I could move? I got you. Here we go. Is my x allowed to come down?
No.
Because it's missing a what?
Log.
Yes, because it's missing a log, I can put the log in. So you can say, I'm going to bring that down as long as I say x log of, can we just say 1.12?
Absolutely.
Thank you, buddy. If I logged the right side, I have to log the left side. Now, let me tell you what I just did, because I could have done this in two different ways. Before I moved that x, I could have just said, hey, I feel like logging the left side, and therefore I feel like logging the right side. I could do that, and therefore, all I did is I multiplied a log to both of these. By doing that, now you might see this a little easier. I can bring that exponent out front. Okay? You all right with that?
Yeah.
Okay. Now how am I going to get x by itself? Divide by? Log of? You know it. I know this is a little funky because we just haven't had these values. So now I want everybody on your calculator. I believe, do I have that 67.1? I sure do. So I'm going to do log of, up arrow, get that 67.1, divided by log of 1.12. Did you get 37?
Yeah, I did it in a different way.
Yeah, great.
Can you not?
Which way did you go, Sammy?
I just did log base from 0.12 to 67.1 equals x.
Say that one more time. Log base.
1.12 to 67.1 equals x.
Yeah. So you're saying once you got here,
It just like doesn't, you don't have to divide, you just can go straight from the root to that.
log base 1.12.
It's like, you know how we did like the root?
Of 67.1 equals the x. So you're saying, okay. Yeah, that's perfect. And so when you went into your math option, math up arrow, log base of 67.1, I'm going to go get that number, boop. And then, oh, no.
Wait, okay, so
Math up arrow
Saved like 3 steps.
of 67.1. We got the exact same. So you had to think of this.
Like when we
Yeah.
rewrote it.
Wait, that is what I did, you guys. That's what I did the first time. Silly me. Okay, look at what she just did. Don't you agree? This was my base to that exponent. So she just said log of that base. I just left off the log. That's my bad. So you guys, this is the base. So we'd say log of that base, because this is exponential form. Log of that base. And then she just circled around. Let me do this in yellow. Log of that base around the equal sign of 67.1 equals x. I love that. I just left off the log sillily.